Hello and welcome to another lesson on conditional statements in Python. In this lesson, you will learn how to use conditionals to find the factors of an integer. You will also learn how to create a list or array in Python. So the modulo operator, which looks like a percent symbol, can be used to calculate the remainder when dividing two numbers. Here's an example of the modulo operator being used to find the remainder when 30 is divided by 4. Now, I'm going to open the Python shell. And we are going to evaluate these statements here. So 30 modulo 4 gives us 2. So when 30 is divided by 4, there's a remainder of 2. Okay, so 4 goes into 30 7 times. Okay, and so 4 times 7 is 28. And so there's a remainder of 2. Let's try now 30 divided by 5 and see what that gives us. So that gives us 0. There's no remainder. 5 goes into 30 evenly. So this also means, yeah, that 5 is a factor of 30 since 5 goes into 30 evenly. So let's write a function that finds the factors of any whole number by using the modulo operator. We're going to open a new file in Python and name it factor calculator. So let's do that. File, new, and close this. I'm going to save it as factor underscore calculator.py. Save. And before we write the program, let's first go over how to create a list or array in Python. All you need to do is give the list or array a name, such as, let's say, factor list in the following way. So let's add that in. I'll just type this in here for now. So factor list. So now the second. So normally when we define variables in Python, and if let's say there's two parts to the variable name, we will usually capitalize the second part of the name. So list in this case, we are capitalizing, and factor starts with a lowercase f. So opening square bracket, closing square bracket. So this is a way to create an empty list in Python. Okay, so we're going to create a function. We're going to define this function. So define factors, and it's going to accept this argument or this parameter, the variable number. Now, there is a way in Python to have basically a description given of what the function does when the user is using the function, okay, or the function is being run. And so this is called a docstring. And so in order for us to have a docstring, what we need to do is we put 3 single quotes, and then we describe what the function does, or what it returns in this case. Returns a list of the factors of num. Okay, so this is known as a docstring. And we'll see what it actually does afterwards once we run the code. So factor list equals opening square bracket, closing square bracket. I'm going to just erase this for now. So I'm creating a list called factor list and then an empty list for now. Okay, now for I in range 1 to num plus 1, colon. So we're going to use a for loop here in order to get the factors of the number. So there's some iteration that is required here. Now, if the number, when it's divided by I, if it's equivalent to 0, so now this is an important operator. So this is an operator used to compare two values, okay, or two strings in Python. Okay, so a single equal sign is used for assigning a value to a variable, while two equal signs is a comparison operator that checks if one expression is equal to another expression or one value is equal to another value. It's a comparison operator. Okay, colon, factor list dot append I. And now we're going to return factor list. So this function returns the list of factors. Okay. So what have we actually done here? So we've defined a function that first creates an empty list where factors of a number will be stored. We then use the for loop to find the remainder when the number stored in the variable number is divided by I, where I is any number from 1 to the number entered by the user. We use num plus 1 in the for loop statement because we want to divide the number by itself. Recall that in the for loop, this normally is always going to be 1 less, right? So if we just put number, and let's say our number is, let's say 10, right? The loop would only go to 9 just because Python starts counting at 0. Okay, so 1 to 10 would actually be 0 to 9 for the values of I. And so that's why we need to add 1 to this so that it actually ends up, the number actually does end up being divided by itself as well. So if the number is divisible by I, which means that num modulo I is going to equal 0, then what's going to happen is the factor is going to be added or appended to the factors list. So this dot append is a function that adds a number to the list, in this case only if it is divisible by I. Finally, the function returns the list of the numbers that are factors of the number that was originally entered. So let's try running this and seeing how this works. So I'm going to save this first. So let's save. And so we run this. Now, notice nothing is displayed initially. So in order to actually use this function, we're going to have to enter factors, the name of the function, and then in parentheses, the number that we want to find the factors for. Now, notice the docstring over here. It tells us what this is going to return. It says it returns a list of the factors of the number. Okay, so it's basically a description that tells the user what the function returns. And it's up to you what you write ultimately. Okay, it's almost like a comment. Okay, so let's try 20, then enter. Now what we get here is we're getting only, interestingly enough, um, only one number here. And the reason for that is probably because there has to be an error somewhere in the code. And so we're gonna have to backtrack and look at where that error might be. Now, the reason why it wasn't working earlier is because the indentation here is actually wrong. This return statement actually has to be outside of the loop. Okay, so it actually has to be aligned with the for here. So it means it's actually outside of the loop and it's returned by the function. So indentation is very important in Python. So if a mistake is made in it, then the function doesn't work as expected. So let's try running this again. I'm gonna save. And now let's try factors of, let's say, 30. And now we see the factors. So 1, 2, 3, 5, 6, 10, 15, and 30. Okay, so it's important to be aware of the indentation, that this has to be whatever the function is returning actually has to just be kind of one indentation to the right of just the function definition and should not be in the loop itself. It should not be in the if statement, because originally I think it was actually in the if statement. So that's not correct. And also it shouldn't be in the loop. It should be outside the loop. Okay. Okay, so what you're going to be doing is you're going to write a function that finds the greatest common factor of two possible integers. Incorporate parts of the factors function we defined earlier into the greatest common factor. So you can call this function GCF. The GCF function should accept two whole numbers, the factors of the first number, and the second should be stored in the list factors 1 and factors 2. To find the intersection of two sets of numbers, the factors that are common to both numbers, use the dot set function in the following way. So if we want to find numbers that are common to the first factors list and the second factors list, we use the set function. So set and then factors 1 dot intersection factors 2. So it finds what's common to both lists, basically, is what this is doing. To find the greatest number in a list or array of numbers, use the built-in function max that accepts a list. Okay, so good luck completing this exercise.